Okay, so quite a few of you have told me that you're struggling with specific heat capacity. So we're going to go through this together. You guys can make notes as we go along. So firstly, the first question is, well, what is specific heat capacity? Here we've got two different objects, object A and object B, right? And in it, I've used these circles to represent the amount of energy that they can take before it causes a 1 degree change in temperature. So the key is 1 degree change in temperature. So if I go with this one, let's say that the circles represent 1 joule of energy, just to make it really simple. So I've got 1 joule of energy that's gone into there, another one in here, another joule of energy in here, and finally 1 more joule in here. Right, so we need 4 joules of energy to cause a temperature change of 1 degree Celsius when the object has a mass of 1 kilogram. So if we now do the same for box or object B, right, and we say, well, what's the specific heat capacity of this? Well, that is basically saying Celsius, right? And the answer to that is 2, right? So here the specific heat capacity of this object B is 2 joules per kilogram degree Celsius. I'm going to look at the units in a bit, okay, so don't get too scared about that yet. But that is basically what specific heat capacity is how much energy is needed to raise the temperature of a 1 kilogram object by 1 degree Celsius. Okay, so now the next part is, well, what is the equation for specific heat capacity? And here, this is how I always teach it, it's my rap name. And yes, I am a rapper, believe it or not. You know, the big fat cat sat on the mat and it was listening to Tupac and all that good stuff. You can actually buy my album on iTunes, right? You can buy it on iTunes. And what is the name? What is my rap name? Okay, my rap name is MC, because obviously all rappers are MC, Delta T. Right, so MC Delta T, and the strap line for my album is Can You Feel My Energy? So we've got E equals MC Delta T. Right, and so that is the equation for specific heat capacity, guys. It's energy equals mass times specific heat capacity times change in temperature. So there you are, energy equals mass times specific heat capacity times change in temperature. So if you imagine that we need to do a triangle for this equation, well, that's a multiply sign, that's a multiply sign, and of course the question is, well, what's going on top? Well, if that's mass times specific heat capacity times change in temperature, then M times C, which is specific heat capacity, times delta T, which is, the delta is the triangle, and T is of course temperature. Now you might see this written another way, okay, you might see it written as delta theta, and that's absolutely fine, they are both correct, okay. And then finally, of course, E is going to be at the top. Right. So what are the units for each one of these? So you should know the units for energy, because all energy is measured with the same units. Of course, it's measured in joules, right? Now guys, remember, as soon as you learn a new equation, you write it in the back of your book. Mass is measured in, you should know this one as well, in kilograms. Temperature is measured in degrees Celsius. Now, well, what is specific heat capacity measured in? Specific heat capacity. Now, one of the skills that I hope you guys are learning as we go along is you can work out the units for anything. So for example, I want to know what the units for specific heat capacity is, so I'm going to cover the C. So my equation is E divided by M times delta T, or delta theta. T, I'm just going to write T, of course there needs to be a triangle there, but I'm just going to keep it simple. So we can get the units from this now, because what we can say is C is equal to joules divided by kilograms multiplied by degrees Celsius. And there you are. Just by knowing the equation, we can work out the units. Okay, so that's the units for specific heat capacity: joule per kilogram degrees Celsius. Right, so that's that. So far what we've looked at, just to recap, what is specific heat capacity? It's the amount of energy needed to increase the temperature of an object by 1 degree Celsius when that object has a mass of 1 kilogram. The equation for specific heat capacity is E equals mc delta T, or theta. Basically it's the angle sign instead of T, same thing. What is the triangle? E goes at the top, mc delta T, and this of course leads us on to a nice example question. So again guys, as always, we use Andrea's method. So we're going to read the question, and it says a 1 kilogram block of copper has a specific heat capacity of 385 joule per kilogram degrees Celsius. There was a temperature change of 16 degrees C. Calculate the amount of energy needed to cause this temperature change. So from this question, what it's asking you really is, what's the energy required? So that's what I don't know. Then the mass of this, well, it's telling me in this question that it's 1 kilogram. In a different question it might be 3, might be 7, might be 22.5, doesn't matter. This is an example question. The specific heat capacity for this is 385 joules per kilogram degrees Celsius. And the change in temperature, now it's been nice, this question, and it's told you that there was a temperature change of 16 degrees Celsius. So 16 degrees Celsius. So all we do is we look at our triangle to work out E. Well, I'm going to cover up E. E equals M times C times delta T. Remember, C is specific heat capacity. So again guys, this is Andrea's method. This should be nothing new to you. And so if I've got a calculator here, I've got my phone, so you guys will have calculators. So it's 1 times 385 times 16. Oops. E equals 6,160 joules. Right, and that's it. That's your end answer. So if we go to an example number 2 question, it says here, a 1 kilogram block of glass has a specific heat capacity of 792 joule per kilogram degrees Celsius. The initial temperature is 27 and it's heated to 78. Calculate the amount of energy. Again, this is asking for the amount of energy. So our temperature's gone up because it was 78 at the end, but it started 27, so it's a positive temperature change. So it's going to be 78 take away 27, 51 degrees Celsius. Right, so that's that. So now we've got our change in temperature. Notice in the first question it told us what the change is. In this one we have to work it out. So again, E equals mc delta T times 51, which is 37,179 joules of energy it took to raise this by that much, right? This block by that much amount, So that is, and basically guys, remember, they could ask a question where they give you C, they give you E, and they give you M, and they might want you to work out T. And that is literally all there is to specific heat capacity.